This time we will see another example on kinematics of a rigid body. So what this example is saying, the angular position of a car traveling around a curve is described by a function. So this function is dependent on time. It is important to note it. Yes, uh, if a function is dependent on time, we can do the calculus, differentiation or integration with respect to time. That is something. Whatever the variable, we have to do the integration or differentiation based on that variable. That is important. Where t is in second and theta is in radian, that means this displacement is in radian, angular displacement. What is most nearly the angular acceleration of the car? So we need to find acceleration. Displacement is given with respect to time. At the beginning means time is 0. So what we saw from our linear kinematics, so a is dv by dt, that means acceleration is dv by dt, then b is s by t, so d square s by dt square. That is for linear. Same equation for angular. Alpha is d square theta by dt square. Here s is my linear displacement, theta is my angular displacement. So same equation, just different format. So you can see that alpha is d v. This time it is not v, it is omega, because it is angular. Then we got d square theta by dt square. That means we have to do differentiation twice. Okay, so if I do first time, what will happen? It is given 15t 2t square minus 6t to the power cube plus 5. If you do first time, differentiation means we decrease the power by 1 and multiply the initial power. So 15t, it will be 15. Why? Okay, 15t will be 15. Why? So it was say 15 t, after differentiation it will be 15. Why? Because say power initially was 1, so we multiply by that 1 and then decrease the power. That means t1 minus 1, so it is simply 15. Then when that means okay, I multiply it by 1 because of power comes down and then the power decreases by 1, so 1 minus 1 is 0. T to the power 0 means actually 1, so it is 15. So this way I got then 2t square, so 2 will come down, become 4, and the power of t become 1, decreased by 1. Then here the power 3 will come down, it will become 18, and then power becomes 2, because it was 3, now it is 2. Why it is there is nothing here? It is actually 0. Differentiation of any constant number is 0. How? Say what is that number? It was 5. Okay, so 5 and nothing here. That means there is a power. If I say t, it was t to the power 0. So if I do the differentiation of this, so what will happen? My 5 is here, this 0 will come down and then the power will decrease by 1, so 0 to minus 1. Now as I am multiplying by 0, whole thing becomes 0. This is why there is nothing here, there is 0 here. Now, or you can memorize a differentiation of any constant number is 0. Something else, differentiation means it's a slope of this number. There is no slope here, it is a constant number, so it is 0. If I do second time, this part will vanish, this part will be only 4. And why 4? Power of t is 1 back, and then power will become 0. So t to the power 0 is 0, sorry, t to the power 0 is 1, so it is 4. And this 2 will come down, 36, and t it will be t because power will decrease by 1, so 36 t. So that is the product of the differentiation after 2 times. After 2 differentiation we get this number. Then it says at the beginning, what is the acceleration? So beginning means t0. Inside t0 here you get acceleration is 4 radian per second square. Why it is this unit? Because theta is radian, time is second, so radian per second square. Now if the question asks what is the acceleration after 20 seconds, insert the value here 20, whatever you will get. It looks very simple, but again very important. So we will wrap up here. In the next video we will see another example.